Francis. I'm actually a Swiftaholic. So I'm going to hopefully by the end of this talk we'll convince you that Swift is in a great place now and can be used through most parts of your business. So just to kind of set the scene, over the next 40 minutes or so, I'm going to basically talk about where Swift can be used, what sort of applications you can build, where you can use it, and kind of workflows and that. But just to step back a bit, it's kind of give an overview of where Swift is now and basically the benefits it gives you. Just going to go through the history of it very quickly. So back in 2014, Apple announced Swift, and I must admit, it was a big surprise. Up to that point, Objective-C has been their main application development language. It served Apple very, very well. But Objective-C is quite an old language. It's got a lot of legacy. And you know how Apple like push things forward very, very quickly. They decided to release a new language called Swift. And it's designed to sit alongside Objective-C. It's an alternative to Objective-C. It kind of targeted the same frameworks, the same Cocoa frameworks that Objective-C did. But it gave you a lot more benefits, potentially, especially if you're new to development or you're coming from a different kind of background, maybe Java or Python. So I remember sitting there watching the keynote, and there had been rumours at the time that Apple were going to release maybe a version of Xcode for the iPad, and then Tim Cook announced Swift. And I must admit, I've been pulled off the floor. I was pretty unhappy at that point. I've spent years learning Objective-C, and so why did I need to learn another programming language? So after a few weeks, I dived into the code, dived into the documentation, and there were a lot of benefits. And I was quickly turned around, and I became a Swiftie. Okay. Now, when I got home and I announced to my family I was a Swiftie, my children, my street cred basically raised. They assumed I was talking about a certain American singer, and I was now a fan of hers, and so for 5 minutes my children respected me. But when I explained to them, no, this is actually Apple Swift, that all went away, and so we're back to being a developer again. Okay. So why Swift? Well, the main reason they brought Swift out was really as an alternative to Objective-C. So who's played with Objective-C? Who's actually seen some of the code? Yeah. So the syntax is probably not nice syntax. The syntax is like alien from most other languages. So Swift itself is meant to be kind of an easier, simpler, cleaner, more expressive language. And it's certainly easier to read. If you've come from another background like Java or Python, the code is much more readable than Objective-C. Objective-C has a lot of @signs, asterisks, lots of kind of nested square brackets, and it's maybe slightly hostile if you're kind of new to it. So it's much cleaner. Swift does away with a lot of the kind of boilerplate code you need for new apps. When you create a new app, there's always a few tasks you have to perform, and Swift will do away with that. And so you get kind of cleaner projects we can start off with, and the code is much easier to read. And if you're new to development, this is certainly an easier language maybe to pick up than Objective-C. So I'll give you an example. Here's kind of two templates. These are the command line templates, so the command line tool templates from Xcode. So on the right, we've got the Swift template, very clean. You can ignore the green lines, there's comments. So the first line imports a framework. So a framework is basically a collection of APIs. So there's many frameworks for different services. So we've got a nice import command. We've got the standard print hello world command to print out that string to the console. If you compare it to Objective-C, it's slightly more, maybe more awkward to read. We've got a hash import first of all. We've got angled brackets surrounding the framework. We have to specify the header file for the framework. We've got this main function that has a memory pool set up. And then we finally get to the meat of the application, which is NSLog, which is kind of the equivalent of print from Swift. So immediately, you can see the benefits. You get kind of cleaner projects as you kind of start up. And it's more readable. Any Python users here? Yeah, okay. So if you come from Python, for instance, there's a lot of similarities. A Python developer could quite easily read a lot of Swift code off the bat, really. So you've got kind of side-by-side comparisons here. So on the left, you've got Python, on the right, we've got Swift. So you've got an example where we create two variables, hold a string. The only difference is Swift kind of enforces this var keyword or let keyword to find whether it's a constant or variable. Here we've got another variable to store an integer. Again, very readable, very, very similar. We've got two variables here, A and B, and we're doing a comparison and running some code based on if that comparison is true. Again, very, very similar in their kind of constructs. And we've got a for loop. So here I'm going to create basically an array. So an array is a collection of items. So here I've got a collection of numbers. And we've got a loop that will kind of cycle through it. And again, the syntax is very similar in kind of both languages. And also, the more in depth you get, obviously Swift does kind of gear off a bit on a tangent, and you get more and more complicated APIs, etc. But as you start off with Swift, it should be pretty familiar. Okay. Another advantage is we kind of gone away from this kind of C legacy. So with C, you often end up having pairs of files. You have this kind of header file, this implementation file. So the .m file would be where your code would sit. The .h file would kind of declare what your code did to the kind of the outside world. With Swift, we've got a single file, so it makes it much more friendly when it comes to scripting. Okay, like Bash scripts are single files, Swift-based single files as well. Okay, kind of pros and cons here, I guess, in this one. So one thing Apple have done is try to make Swift very safe. So there are a lot of common errors that developers, including myself, kind of fall into. And Swift attempts to kind of knock those out immediately when the app's compiled. Okay, so there's a few things it tries to enforce. One is brackets. So I think Clay mentioned earlier on the go to fail error in Apple's SSL stack. That potentially could have been solved with some brackets potentially. So Swift kind of enforces brackets all the time. Some other languages you can kind of drop them, kind of optional. One thing that will, I guess, kind of bite you initially if you're new to this is kind of the type safety. So Swift does actually kind of enforce that you understand what sort of data you're using, type of data. So if you've got a bit of code that expects a string, you cannot pass it any other type of data. And sometimes Swift can infer the type, sometimes you have to be explicit and specify the type of data you're using. So it may seem like it comes up front, but you do end up with safer code. But if you're not used to this, again, it can be slightly awkward. Okay. One really big advantage is Swift is now open source. Okay, so Swift.org is the site for the open source environment. So Swift 3, which is the current version, has been open sourced. And Apple basically taking contributions from the community. So a lot of Swift 3 feature sets were from the community. So it's actually a language we can actually influence now by making suggestions. So on there you've got it's really good community. Apple supply obviously the OS X compiler, which is Xcode. You've got a Linux compiler. The community are working on all sorts of ports. There's a version for Android coming. There's a version for Windows. Someone's ported to the Raspberry Pi. So it's a really active community. Okay, but mainly Swift can be used everywhere on the Apple platform. So obviously you can build native apps. So your typical iOS, Watch, tvOS apps. You can build Mac OS apps, but then you've got other ways of running Swift code. You've got the playgrounds, you've got REPL we'll look at, you can create command line tools, you can create scripts like Bash scripts you can do the same thing with Swift, and you can even start creating server-side apps. Okay. Compatibility is great, so even though Swift was introduced with iOS 8, it's backward compatible with iOS 7, so I assume no one is running anything below iOS 7. No? Hopefully not. Hopefully not. And Mac OS 10.9. Okay, so it's got reasonable kind of support base. So all's good, yes? Excellent. Okay, so we're all converted. So it can't be that perfect. There are a couple of downsides to Swift, I guess. The biggest one, which is kind of, I guess, stop some people from adopting it, and maybe as administrators, stopping people from using it as a kind of scripting language, is the following. So since Swift has been out, Apple have maintained binary compatibility, which basically means is any application you build, as long as you don't modify that application, that will run on the current version of the OS and future versions. However, your source code can change, and Apple have been very aggressive with changing the syntax of Swift through the last 3 versions. As an example, I can't take a project 6 months ago and recompile it with maybe a few tweaks just to kind of update it. Okay. Now, hopefully that's the end of it. So Swift 3.1 is due pretty soon, actually, and the goal of that is to maintain source code compatibility going forward. So hopefully, that excuse now is no longer valid. Okay, so a good example how the syntax changed. This is a command to count how many characters in a string. So when Swift first shipped, version 1, we had this function called count elements, and you pass it the string, and it just counted the characters, and away it went. then we had a point release of Swift, and that was renamed to count. And then in Swift 2, they completely changed it and made it a property of the string, which is characters.count. And that's just one example. There's hundreds of examples where the syntax has dramatically changed. Now, Xcode does come with migrator, but it doesn't migrate everything. Okay, so there's always some effort to try and update your projects with the latest syntax, but hopefully from now on, this won't be an issue. Okay. One of the considerations I make for admins is one thing that Swift does for compatibility reasons, it embeds the version of the Swift library it was compiled with into the actual binary. It's so that the app has got a consistent version of Swift to run with going forwards, which doesn't mean your application do get slightly bloated by about 6 to 8 megs, depending on what you're doing. So as an example, this is a screenshot of the default command line project. It doesn't do much, it says just print out hello world. So the Objective-C version is 20K, the Swift one is 8 megs. Okay, so if you're pushing out Swift binary files, maybe through some sort of management system, that maybe is a consideration to kind of think about. Okay. And then, obviously, Swift is quite easy to get into, but like all languages, the deeper you get more complex APIs, you need more knowledge. But it does tend to scale with your learning curve, okay? So it's not too aggressive. But there are some things that sometimes trip people up. Probably one of the worst ones are optionals. If you're not used to this, optionals are a way of handling nil data. And really, at the end of the day, it's basically a choice of how you use question marks and exclamation marks. If you get this wrong, you get runtime errors and all sorts of problems, basically. So that's one of the things you kind of have to get over. We've got type safety I mentioned. There's a load of APIs. They're not hard to use, but again, if you're new to this, potentially some things in Swift may be harder to do or more complex than maybe the Bash equivalent. And asynchronousy. So some of the calls you'll make will be asynchronous. Okay, so instead of being kind of like a script which is kind of very linear, you can start running calls off on different threads and it will be asynchronous. So again, maybe a slightly different mentality on how you kind of program. So Swift has been climbing up the ranks. This is some stats I got from June last year, so it's kind of the latest one. So Swift is allegedly about the 17th most popular programming language out there at the moment. It's the first language to hit the top 20 in its first year. And it's really been taking market share away from Objective-C, really, because a few years ago Objective-C was number 2, I think, and that's kind of dropped as kind of Swift has climbed up. So, and I guess you can see it's more and more. So Swift will climb up, and Objective-C will probably decline slightly. So where can you use Swift? Okay, so obviously the most obvious example are native apps. Okay, so you can build Mac OS apps, iOS apps, TV OS apps, command line tools. You've got access to all the frameworks Apple make available, all the Cocoa and Cocoa Touch frameworks, native UI. You can build enterprise apps, which you can digitally sign. So going back to Gatekeeper earlier on, that makes it very Gatekeeper kind of friendly. And you get access to the stores, App Store, Mac App Store, and TV Store. And Apple got a full suite of tools to back that up. So these are all free. Okay, you can get them from the Mac App Store. So you've got Xcode, which is the developer environment. You've got Interface Builder for your UI, instruments for profiling the app. You've got a simulator for running your iOS apps on the Mac. So a really good versatile set of tools. Okay, and also they've got a developer program to actually back it up. So out of interest, who's got a developer account? Maybe a personal one? Yeah. Okay. So there's a couple of programs you can sign up to. So obviously you've got the Apple Developer Program for the App Store, you've got the Enterprise Program for building enterprise apps. But if you haven't got an account, get the free one. You get access to all the apps. The only thing you can't do is distribute the apps. So you can't submit them to the App Store. You can run iOS apps on your personal device. So the free one is a really good starting point. And also you get access to all the documentation and all the goodies on the developer site. So if you haven't got an account, I strongly suggest at least go for the free one. Okay. So you've got native apps. The second approach of writing kind of Swift code are playgrounds. Now, playgrounds are quite interesting. All a playground is basically a folder of resources. In that folder, you have a Swift file where your code goes, and you can also embed resources like images. And it's really a kind of an interactive document. So every time you make a change, it will just rerun that code over and over again. So it's a nice way of kind of experimenting with blocks of Swift code you want to play with. Traditionally, if you wanted to experiment with any application or any code, you'd have to build a kind of a demo application. You'd have to put your code inside it. You have to compile it, run it, go back and edit it. Well, this gives you a very quick way of kind of prototyping or experimenting with your code. I guess the only downside is you're not getting any real experience of actually building real apps. Okay, so I wouldn't spend. I think initially you're probably better off building real apps, but once you get kind of into Swift, the Playgrounds is kind of a nice way to kind of experiment. So I've got a quick example of this. Now I did a sacrifice to the demo gods last night. My firstborn was sacrificed for this. And I got my younger one on standby, so if it all goes wrong, okay. So this is basically a playground, okay. What it is basically it's a package of resources. So you can create one of these just by going to the new playground in Xcode, okay. And the idea is as you make changes, it just keeps running the code over and again. So I've got some sample code in here. So as an example, I've got a variable that will create strings. So if I make a change to this, it'll run it. And I can get some feedback on the right hand side. You get the results back of what's happening. Here I've got a calculation. So I've got basically I'm going to create a variable. I've got a calculation. Again, it immediately calculates the result. And maybe if I'm experimenting, maybe it's my expenses, and I want to kind of make some changes to my expenses. In real time, it kind of obviously re-execute it every time I make a change to that code. So I can make a change to it, and it recalculates it. Here I've got a loop. So this time it's going to create a loop, and basically it's going to just create a sine wave. Okay, so it's going to basically plot out the value of that loop, so I can get very visual kind of feedback. Even some UI elements. So in this example, I'm going to create a UI color object. So basically, I'm going to create a color object, and again, the playground will give me a representation of that color. I can go in and make changes to that color, and again, in real time, update it for me. Okay. This example is going to create a string that's got a certain font, certain font size, and again it just gives me a representation of it, so I can go in and maybe change the font size. I can go in and change the colour to a ghastly yellow, and you get kind of real, that's a bit washed out, but there you go. Okay, so like so. And this example, I'm going to come back to this one actually later on. I needed an example function to run. So this is a function that calculates prime numbers. Okay, so we can use this over and over again. So basic idea is we can specify what number we need to calculate primes up to, and then it basically return an array of all the primes up to that number. Okay, so that's the function, and we can call it just by calling its name primes, specifying how many primes we need, and it calculates up to that. So there's a result basically in the console. Okay, and again, if I make changes to this in real time, it just recalculates. Okay, you can even do images. So here I've got an image. There's actually an image embedded into the playground. So again, I should load up the image. It would preview it for me. If I change the image, it should reload it immediately. Okay, so it's kind of a very visual tool. Okay, so that's kind of Playgrounds. It's a very nice way of experimenting with your code. There's also an iPad version. If you haven't seen that, it's a free program, and it's quite a nice tool. It's got loads of tutorials on it on how Swift works. And what's nice about the iPad version, not only does it teach you Swift, it will teach you kind of logic behind programming. So you get kind of little logic tasks, and you've got to kind of solve them with Swift. And you can export your code from the iPad back to the Mac, etc. So if you haven't seen that application, download it. It's free, so it's worth looking at. So that's kind of Playgrounds. That's a nice way of experimenting. And then going to the command line, I guess you can call this the playground equivalent of, or the equivalent of Playgrounds in the command line. There's something called REPL, and REPL stands for Read, Evaluate, Print, and Loop. So what REPL does is you can enter code for this kind of interactive shell. It will read each line one at a time. It will compile it, or evaluate it. It will print the result out, and then loop back basically to the beginning again. So again, it gives you another way of kind of experimenting with Swift for the command line. And we can get to it via the Swift command line tool. So if I go back to my demo and bring up the terminal, we can type Swift, and it should launch in a second. It takes a few seconds to launch. And basically you get kind of an interactive shell where we can start typing code. So I can do a very simple, for instance, I can't type in front of people. There you go. Okay, it's very simple print commands, and it outputs it. We can do a loop. So I can type a loop in, like 1 to 100. And what's nice about this kind of interactive environment is it kind of follows what you're doing. So if you put a command in that requires a few more lines of code, so this example, we're going to do a for loop. It won't execute it until finished. You realise what I'm doing, so if I return, it won't execute it I can carry on entering the code, so I can print out the loop counter, and then when I close it off and hit return, oops, what did I do wrong? Oh, sorry, two missing dots, sorry, yeah, sorry. Live demos, right, where's the second child? Okay, bring on. Okay, so if you go back then, we can go down and hit return again, and it loops, there you go, it loops. And you can get back to the code again, using the up arrow, I can get back to the previous kind of function or statement, I can go back and make changes to that, so I can maybe do 1,000, and come down and can re-execute it, like so. And again, if I go back to that prime example, so I'm not going to type this in, it's just too long, I can just copy that function in, so it's the same function I used in the playground, I can paste it in, okay, the function is now there, I can then run it by calling primes, specify how many I want, 100, hit return, and it calculates them. I can recall it again. Oops, be very careful with this, make sure you hit return at the end of it, and again recalculates it. Okay, so again, I guess it's the command line version of kind of playgrounds really. And to come out, it's just Control D, and you can come out again basically. So that's kind of REPL. And some companies have done some interesting things with REPL. IBM have kind of webinized it. They've got basically a version of REPL running on their IBM Cloud Solutions. They've basically ported to Linux. Each of these sandboxes runs in a Docker container, and you can basically run Swift codes using their website. So it's all updates. You can put code in. You get the same output as we had with REPL or very similar to the playground. You can export the code back out and save it back out. So again, a very nice way of kind of playing Swift for a browser. And while we're on the subject of IBM, they're doing some interesting stuff. They've got a kind of framework called Katura, which is basically a set of Swift server-side APIs. So you can build Swift server apps and distribute them. So you can now have Swift at the back end. They've got a load of tools to help you manage these server-side apps using Xcode. So they've got some tools that they hook Xcode into their kind of cloud solution. But there are other companies, Vapor, Perfect, and Zuru are other examples of server-side Swift APIs. And it's such an important kind of area that Apple actually now formed a server API workgroup to try and standardize on how these APIs are written in the future. So this is definitely an interesting area of kind of development. Okay. Then the next step is scripts. In the same way you can do bash scripts, you can run Swift as a script as well. So we create Swift scripts, these kind of .swift extensions, and we can run them through the Swift command line tool. We can use Shebang to make them more independent, or we can compile them down to the command line tool. There's a SwiftC compiler we can use to recompile them. So again, I've got some examples of this. So, let's clear this out a second. Okay, right. So, like all good Boy Scouts, I've got some examples here. So, if I change directory, so I've got some example scripts here. So the first one, literally very simple. All it is basically is, I'll zoom in, it's just a very simple print command, nothing really fancy. So it's just a very simple Swift command. And we can pipe that through the Swift command line tool. So if you type Swift and hit enter, you get REPL, as we saw earlier on. So actually REPL. But what I can actually do is just type Swift, and then I can pipe in a Swift file and execute it. Okay. I can do the same thing with that prime function. So there's the prime function. So literally it's just a text file with the prime function in, and we're going to call it and specify how many primes I want as an example. Okay, so again I can just do Swift, and I can just do the second file, and again execute it. Okay, and if I make changes to that file, just do 100, and save that off. I can rerun it again through Swift, and it re-executes it. And also manually run it through the Swift command line tool is a bit of a pain. So one of the things you can do also is you can add a shebang line, like Clay mentioned earlier on. So we can point it to the Swift environment. Again, nothing else has changed, it's the same Swift code, but now we're going to have the shebang line in there. And now this is independent, so I can now run this just by running a normal shell script. It executes it. Okay, now it needs the execute permission, like all shell scripts, okay, but nothing unusual there. And you can do the same trick as well. If you rename these to .command, they become double-clickable, and you can just launch them. It opens up a shell window, in terminal and executes it, so you can make them a bit more friendly maybe. Okay. The other thing you can also do is you can add arguments to these script files, okay, so you can run them and pass arguments in. So if I open this one up here a second, so there's a class called command line. So command line.arguments gives access to the arguments you passed to that script. So if I just run this script a second, it doesn't do anything other than, in fact, let's bring it back up again, it doesn't do anything other than just basically print out what arguments was passed into it. So if we run this script up by itself, let's do number 5, notice it's printed up one element. So you always get one argument, which is basically the path to the script itself. So any subsequent argument will be additional to this one. So if I run that again and pass some arguments in, so I can maybe put ABC, 1, 2, 3, I don't know, ADF, okay, it now prints out the arguments, okay. So the first one is always the path to the script, and then we've got the other arguments that are passed in. And you can get to each individual one. It's basically an array, so if I show you, on the arguments command, we can basically get access to each item. They've got index numbers, so 0 being the first one. So 0 always exists. That's always the path to the script, and then you can get additional arguments based on what the user passed into that script, just by reference to the index number. So if I run that version of the script, so I don't know, ABC, 1, 2, 3, okay. It's now broken them out, okay, so it's listed each argument separately. If you stay careful with this sort of stuff, Swift is very sensitive to missing data, so if I run this again with no arguments, I've got no safety checks, and it's going to crash because I'm trying to print out the second, third and fourth argument, and it doesn't exist. So yeah, you need to be slightly safe with this sort of data, so obviously like all scripts, you know, for housekeeping to make sure data exists. Okay. So you can do arguments. So again, then we can make use of those arguments. So for instance, I can go back to my prime example, and I can take an argument in and specify how many primes I want now. So so there's my prime function as before. Here I'm just printing out, doing two things actually. I'm printing out, first of all, how many arguments got passed in. So if you do a count on the arguments, you can see how many are passed in. So if you get more than one, you know that an argument is passed in, because the first one is always exists. And then I'll just basically print them out. But then what I can then do is I can check, you know, if I've got more than one argument. If I've got more than one, I know I've got an argument passed in, and I'm going to grab basically that first argument. And one thing I guess to stay careful with, all arguments are passed as strings. Okay, so if you want them in a different type of data, you have to kind of do a conversion. So here I'm converting that string to an integer. Okay, so I can use it with my prime function. So we're going to convert it to an int and store it in arg, and then we can pass arg to the prime function, and now we can specify how many primes to kind of calculate. So if I now run that function up, so if I just do 7, I just run it by itself, no arguments. Okay, so we have one argument, which is the path to the script, but now I can pass in maybe 100, and it calculates hundreds up to 100 to 1,000, so a bit more versatile. Okay, so you can pass arguments in. Okay, you can even do flags. So on the last example, I can do -- help as an example. Okay, so that's probably all familiar with that, yes. Okay, so again, all I've done here is I've taken those flags of the arguments in, and I've got some very simple if statements to check for certain strings I want, and I'm doing something based on that basically. So they're the scripts, but one nice thing you can do, because at the moment this is kind of dependent on either using the Swift command line tool or Shebang, you can actually compile these down to binary. So we have a command called swiftc, and we can take any of those scripts. I'm going to take the binary, the prime one again, okay, so it's going to pass in that Swift file. And if I do -o, I can get Swift to rename the binary, because I don't want to call it -7, so I'm just going to call it primes. That's going to compile it, and now over here I've actually got a proper working binary, which now works as normal binary. So I can now run primes. If I just run it, I get the one argument. If I run it, I get that. Okay, so you can compile all your scripts down to binaries very, very quickly. Okay, so that's the kind of the shell scripting. Now there is, well, that's the script anyway. There's one, I guess, one thing to think about. If you're using Swift or swiftc, it does need either Xcode installed or the command line tools, developer tools installed. So the first time you run these tools on a clean Mac, it's going to prompt you to even get Xcode or install these tools. So that's, again, a consideration you kind of think about. Also, if you compile them, that's no issue. You've got a binary which is kind of independent. So that's your scripts. Then the next stage is integration. So with integration, there may be tasks that you already do with an existing working script, like a Bash script or an Apple script or a Python script. There may be some tasks that are easier done in Bash or Python. So we can integrate it. Swift can call these scripts and execute them and then get results back. Okay, you kind of chain them up basically. So there's a couple of ways we can do this. For kind of Bash and Python, we've got a couple of classes we can instantiate. So we've got this process class, and what the process class does is it lets you kind of launch another program as a sub-process to this program. It's this way of kind of running these command line tools. And we've got this pipe class, which basically allows us to create a tunnel between the two processes. You've got Swift on one side, we've got this other maybe shell script running, and we can use the pipe to get information from one to the other. So we can read the output of the Bash script and pipe it up to the Swift script, and then you can do whatever you need to do. So that's quite useful for like Python, for kind of Bash. Any AppleScript fans? A couple. Okay, it's hanging in there just. Okay. You can run AppleScript. So we've got an AppleScript class that lets you either pass in an AppleScript file, or you can pass in AppleScript text, and you compile it, and you get it to run it. Okay, so again, I've got a couple of examples to show you. So let's clear this out. Okay, so I'm going to change directory. So I've got some Bash ones first of all. Okay, so if I open the first one up, so the first one is basically it's just going to run ls and pipe the result back to into Swift. So basically, we've got a shebang line, that's normal, so we make this independent. We first of all create the process, so we can instantiate this process object to allow us to run a task. And once we create this, there's a few arguments we can pass into it. We've got the launch path and the argument. So the launch path is the name of the kind of the app you want to run. So in this case, I'm just going to get access to the standard environment, which is in my case Bash. And I'm going to pass an argument to it. So I can pass any argument to it. In this case, I'm going to pass ls. So that's the command I want to run. I then create a pipe. We're now going to create a tunnel between Swift and this Bash environment. And we're going to set the standard output on that process we created to that pipe. Okay. Now to execute it, we've got a launch command. So we can tell your process to launch. It's now going to execute that. And once it's executed, we can then read that pipe, see what came back. So to read that, we go to the pipe, and we can ask it to give us a handle for a file for reading, and we're going to read to the end of the file. And this is going to basically give you a data object, which is basically a set of raw data, it's kind of raw bits. So to make it more useful, we're going to kind of convert it. So in this case, I'm going to convert it to a string. Okay, so I'm going to call string, I'm going to pass in that data object we grabbed, I'm going to convert it to kind of UTF-8 standard kind of ASCII really, and I print it out, and then we finally print it out, and so Swift is printing the result out. So if I now run this script up, okay, I should get an ls output. So Bash did the ls, and then Swift grabbed it and kind of outputted it. And you can pass many arguments. So we can take that same script, and we can pass an extra argument to ls. So we can do a comma-separated list and pass in -l for long listing. Okay, the rest of the code is exactly the same. So if we run the second one, we now get a long listing, so with more arguments. But you can run any command line tool. This third one is going to run DSCL to get a user listing. So the only difference is I've changed the launch path. So instead of being the Bash environment, I'm going to point it to the DSCL command line. And then the arguments are going to be the arguments I want to pass to DSCL. So it's going to give you a list of local users. It's going to execute it, and then we're going to read the pipe to bring those results back. Okay, so again, if I run the third one, again, the DSL did the work, and Swift has now got the information to play with. Okay, and you can also run shell scripts. So I've got a very simple shell script here. It's a standard shell script for Bash, and all it does is gives you the status of file vault on that machine. Okay, so it's very, very simple, just for the demo. And then I've got again, in that example, most of the code is exactly the same. The only difference now is I'm creating a variable to hold a path to that shell script. Okay, my launch path is Bash. I'm going to launch Bash up, and as the argument I'm going to pass in that path, that script, and it gets bash to launch that script. The rest of it is exactly the same, okay, nothing different there. So if I run out number 4, if I can't type, okay, hopefully, there you go, okay, so bash went off and got the status and handed it back to kind of Swift, okay. And the last one, just an example of kind of type safety. I've got this one which basically is going to do a curled. Apple have got a JSON feed for all their iTunes listings, and it should go off and get the number 1 album at the moment in the charts. Hopefully, the internet's working. So if I run this first and execute it, so curl's going to go off. It's going to get the JSON feeds. It's going to bring it back. Then Swift is going to interpret that JSON feed and it extracts the album. So just like Ministry of Sound are coming number 1. Which I think is correct. I checked this morning. Okay, so if you look at the script, then most of it again is very, very similar. The only difference is really is right at the beginning, I've got a variable to hold the path to the feed. This is basically the feed to Apple's album charts for the UK. The command line tool I'm going to run is curl. And I'm going to pass it as an argument that URL, so that goes off executes. So we then execute that curl command, and we've got the same commands to read that pipe back. So at this point, once we read it back, we've basically got this JSON feed as a kind of data object. This is an example where the kind of type safety comes into play. And Swift does kind of start enforcing on you to make sure you know what sort of data you're going to get back. So we take this data object, so this is the data that came back from Apple, and we're going to first of all convert it to a dictionary, standard key value pair listing dictionary. So we've got a JSON serialization methods we're going to call. We're going to pass the data object in and get it to convert it, but we've got to tell Swift what sort of object it's going to convert to. So we have to basically tell it it's going to be a dictionary whose keys are strings and values can be any object. If I take this out, Swift will complain, doesn't understand what it's doing basically. So sometimes you've got to be very explicit about what sort of data you're dealing with. So at this point we get a standard dictionary back, and then we start drilling down the keys. So the first key in Apple's feed is the feed key, and that's basically got another dictionary inside it. So you've got to specify it's going to be a dictionary of strings whose values are any object. Inside that we've got an entry key. That's basically an array of all the albums. So we have to tell Swift it's an array of any object, so any items can be of any value. And then we grab the first album, and inside that there's a couple more keys we need to drill down. So there's a title key that has a dictionary for all the information about the album. So again, we've got to tell it what sort of dictionary it is. So again, it's a string with any object. And then we can finally get to the actual item we're interested in, which is the label, which is basically the title of the album. And again, we've got to tell Swift it's a string. And so once we've done that, we can obviously then make use of that information. But all for that process, I have to make sure about the data I was using. Okay, so if you're new to this can be a slightly painful experience sometimes. Okay. As for AppleScript, if I zoom in here, I've got a very simple AppleScript. So if I open up first into the AppleScript editor, this is basically a very simple AppleScript that basically takes an image, and then through the image events, it's going to basically convert that JPEG to 3 different resolutions of PNG. Okay, so if I run this up a second, there's the JPEG file there. If I run it up, what should happen is it should run, and then it spits out those 3 versions. Okay, so that's the AppleScript. It's a standard AppleScript. But if you want to, we can get Swift to execute this. So if I go to the first script and open it up, very, very straightforward. I've got a path to the script, so I'm going to create a URL that's got the path to the script I want to run. It's a standard AppleScript. And then we're going to call the NS AppleScript class, and we can basically pass it that file, and it will compile it, and it'll be ready to execute. And once it's done that, we can then, on that object that's been passed back, we can ask it to execute it and return any errors. Okay. So now, if I run this script up, so I just need to do a quick directory change. Okay. If I run the first script up, hopefully that should run AppleScript via Swift. And there you go, it's now executed it. Okay, so you can do AppleScript, you can do Python, all sorts of things. Okay. You can even embed AppleScript inside the actual Swift file. So I've got the same AppleScript, but now I've embedded it as basically a series of strings. So each line represents a line of the Apple script. You've got to be slightly careful doing it this way. You have to put in kind of the hard carriage returns by doing /n, and where AppleScript uses quotes, you have to kind of escape those as well, because Swift will use them for other reasons. But basically, I've got the same script, so I just basically added it manually into Swift, and then it's going to basically execute that using the same NSScript command. So rather than passing the file, I'm passing it those strings basically. So again, if I run that one up, it should be no difference. It should still execute. And I get my output back, and there's my 3 images. And just to show how versatile this is, I don't know if anyone used this, but a few years ago, Apple introduced JavaScript for UI, or for automation. Actually wrong file. So basically, you can do the same things in JavaScript as you can with AppleScript, using the same Apple events. So this is really the same script done in JavaScript. Okay, it's doing exactly the same thing, and I can use the same NSScript command I did, but instead I'm passing in the JavaScript file rather than the traditional AppleScript file. Okay, so again, if I run this version up, it do the same thing and it executes. Okay, so AppleScript is still hanging in there. Okay, like so. Okay, so that's kind of scripting. Almost finished. So file management. So Swift can do a lot of file management. It's got a file manager class. It can create files, delete files. You can copy files. You can do permissions. But sometimes, if you're doing a lot of file management, Bash can be simpler. So sometimes you may use a Bash script to do the file management and go back to Swift. But Swift can do all those file management tools as Bash can. And it's got lots of nice shortcuts to try and find common folders like home folder, temp, library, and documents. And the last one I was going to show you is, go on a second, is login. So one nice thing we've got in Swift, we can actually write to the log files using either nslog or the new oslog, a command which works with the new unified logging system Apple introduced with kind of Sierra. So it means then you can probably log all your scripts back to the kind of console. So what I've done is, very quickly, I've got 2 minutes left, so I've got a very simple command line tool. Okay, I'm just going to comment all these out a second. Just showing you how this works. Oops, don't do that, do I? Okay, so it's a very simple command line tool. So I'm going to bring up the console. Okay, so standard console. And can you see that okay? Yeah, okay, so it's going to basically run the first command. So the first one is nslog. This has been around for donkey's years. You run nslog, you pass a string into it, and then it output it to the console. Okay, so if I run that up, and if I do a search for foobar there you go. So there's the application process, my logger, and you can see the message. Okay, so that's been around for years. The equivalent now in Sierra is this new oslog command. Okay, so we can call oslog in its simplest format, and again we can pass it a string. So same as nslog, and it works in exactly the same way. So if I run this up, and I can do a search for that message. Okay, there you go. There's my log come up. Okay, so again, there's the process. That's the message I printed out. But one of the nice things you can do with oslogger is you can create custom kind of log information. So one of the things you can do is you can create a custom log where you can create a subsystem, so you can start kind of IDing different parts of your application based on reverse DNS names, and you give them categories as well for different kind of errors. So we can create this custom logger, and then when we use the OS_log command, as well as printing out the message, we can specify the custom logger and what sort of error it is, what sort of information we pipe into the console. So the default one is .default. Okay, so if I run this up, what I can now do is I can do a search on that custom subsystem. Let's do a search on this. And it's going to find it. Okay, so now I've got the same process, same message, but now it now shows me the system ID. But we can also change the type. So we've got 4 other types. So if I uncomment these, we've got the fault. We can do errors. We can do debug, and we can do info. So if I now run this up and go back to the console, you can see as well as having this subsystem, it's got the type as well. So the red one, for instance, is a fault. We've got errors. We've got debug. So you can see now very easily start categorizing your errors from your scripts. Okay, so that's a nice new feature of kind of Sierra. Okay. So I think that's almost done. So that's basically the login. And if additional resources, so definitely get an account and developer site. So definitely sign up if you haven't got one. Apple got a really good book on the iBook store. It's the Swift Programming Language Guide. And what's nice about this book is it's always updated. So Apple are pretty quick at updating it when they release new iterations of Swift. It's a free book, so definitely get that. It gets quite advanced, so maybe only read the first portion. Later topics a bit more advanced. And there's some really good third-party resources. There's a guy called Ray Wenderlich. He's really good. He's got some really good books. A-Press has got some really good books, and so have Riley. Okay, so there's lots of good resources out there as well. So thank you.